Hey guys, welcome to Crown Smart. In today's video we're going to be dealing with chain rule. Now we want to solve the following. Now for number one, we have that our y is equal to, we let y to be this, we let y to be equal to this function. Now if we expand this function, we have this, okay? And also if we differentiate this function, it's the same thing as differentiating y. As you remember, this is y, so we have dy over dx, and this is equal to differentiating this expression because y is equal to this expression which we have here. So we know that our dy over dx is 2x plus 6, but this is not actually chain rule. In fact, this is our normal differentiating a polynomial rule. That's a normal way of differentiating a polynomial. So now we want to differentiate it is using chain rule. Now let's see if this will give us actually the same thing. Now as usual, we let y to be this, okay? Let's say let y equal to x plus 3 all square, and we also let u to be equal to x plus 3 because why we use chain rule is otherwise known as function of a function, is a function containing another function. Okay, so if this is a function, then this function contains another function, so we use chain rule whenever we have such cases. Now we said let u equal to this. Now if u is equal to this, therefore my y is equal to u square. Now what we do is we differentiate this. We find dy over du. This should give us 2u, and we find du over dx. From this equation, which will give us 1. Okay, so we now say, okay, therefore our dy over dx is equal to our dy over du times our du over dx. In normal arithmetics, what we do is cancel these two, but we don't do that in calculus, so we leave it like this. This is actually the answer. So our dy over du is 2u times 1. Our du over dx is 1, so this is equal to 2u, but we can't leave 2u, we can't leave our answer as 2u like this. So what we do, we change it back. So what is our u? Our u is what? From here our u is what? X plus 3. So x plus 3, this is equal to 2x plus 6. So you see it's actually giving us the same thing, and this is true. Okay, so now we want to use the same chain rule to solve a question. X plus 3 raised to the power of 5. Now the reason why we use chain rule is because in the other case we're able to expand this, but in this case, can you expand it to the raised to the power of 5? It becomes more cumbersome and more difficult. So chain rule is the easier way to solve this. So what we do is let y equal to x plus 3 raised to the power of what? 5, and we let u equal to x plus 3. Okay, so what we do next is, okay, we now know that y will be equal to u raised to the power of what? 5. Now if I differentiate this, I'll have dy over du is what? 5u raised to the power of what? 4. Remember how to differentiate. And then if we differentiate u with respect to x, we have this as du over dx. This will be what? 1. So therefore my dy over dx is equal to my dy over du times my du over what? Dx. Now this is equal to, my dy over du is 5u raised to the power of 4 times 1, which is my du over dx. So this is equal to 5u raised to the power of 4 is equal to 5. Now what is my u? My u here is x plus 3. So I have what? X plus 3 raised to the power of what? 4. So this is actually my answer. You can expand this if you want to, but this is the answer. You can leave it this way or you choose to expand it. So we do the next one, which is the square root of x squared plus 4. Okay, which we know is the same thing as x squared plus 4 raised to the power of half by my law of indices. So what we do here is let y equal to x squared plus 4 raised to the power of half, and u equal to x squared plus 4, the inner function. Okay, so what we do next is, okay, we conclude that y is equal to u raised to the power of half because u is this. Okay, now dy over du is simply half u. Now half minus 1 will give us what? Minus half. Now if we simplify this will give us what? Half times 1 over u raised to the power of half. This is equivalent to half times 1 over square root of u. This is equivalent to 1 over 2 root u. Okay, a simple multiplication. Now if we differentiate the u, if we find du over what? Dx, this is equivalent to 2x. Okay, so if you differentiate it, you have 2x, and you differentiate it, you have 0. So we are left with 2x. So my dy over dx is simply what? My dy over du times my du over what? Dx, which means my dy over du is what? My dy over du is 1 over 2 root u times, what is my du over dx? 2x. Let me put this over 1. So this is actually 2x all over 2 root u. This can go cancel this. I am left with x over root u. Okay, but that's not it. That's not it actually. So what we do here is and answer, okay, therefore my dy over dx is equal to x all over, now what is my u? My u is what? Remember, my u is what? X squared plus 4. So that is the answer for number 3. So for number 4, we have that our y here, let y equal to exponential 5x and u equal to what? 5x. Remember, exponential 5x is a function, then 5x on its own is another function. So exponential is another function containing another function 5x. So what we do here is we have that y is equal to exponential u. Now I want you to recall that if we differentiate exponential x, by definition is equal to exponential x. So similarly, if I differentiate exponential u, by the same definition is equal to exponential u. So my dy over du is equal to what? Exponential u, because I'm differentiating this with respect to u. So therefore I'm having it as exponential u. Now if I now find my du over dx, my du over dx, I will have this as what? 5. So by my chain rule, my dy over dx is simply what? My dy over du times my du over what? Dx. This is equal to my dy over du is exponential u times, what is my du over dx? 5. So this is equal to 5 exponential u. This is equal to 5 exponential, what is my u? 5x. I'm changing this to 5x. Remember, u is equal to what? 5x. So this is my answer. If you recall, in my last video I say I gave 3 steps to solve exponential function, and that 3 steps is, first of all, write the function, take the ln of the base, and then differentiate the power, which is what? 5, and at the end of everything you multiply them together. Ln e is 1, so you have 5 exponential what? 5x. So you see, that 3 step is a shorter way to differentiate an exponential function without actually going through all the stress. Okay, so watch my other video to learn the 3 steps how to differentiate an exponential function, and I hope you learned how to differentiate a function of a function using chain rule. Thank you, and please subscribing to this channel will help us upload more videos. Thank you very much.